So we mentioned glaciers in sea level rise, contributions from glaciers. Sea ice obviously doesn't contribute to sea level rise because it's ice that's already in the ocean. It's like ice cubes melting in a glass, doesn't make the glass overflow. Whereas glaciers are water mass that has been moved from the ocean, locked up on land. When it's released, it's going to go back into the ocean and raise sea levels, right? So let's start by looking at loss of sea ice. So here is the historical sea ice loss over 1980 to 2000. You will see many such figures. September sea ice is of critical importance because the northern hemisphere summer, whatever is not melted away in September is going to grow back into the fall and winter months. So the minimum in September is an indicator of how bad the situation is going to get. So here are various models, the average of all models and the best models that agree with the historical observations are shown with the range of models that with the model numbers involved and the number of scenarios and so on. Lots of details there. So you are seeing the best case scenarios of RCP 2.6 and 6.5 here, and 4.5 and 8.5 here. So dashed lines are all models, and the orange solid lines here in all the scenarios are the ones that best agreed with the historical reconstructions. And here you can see the maps for the latter decades 2081 to 2100 for the best case scenario RCP 2.6. If we can make this, it'll be fantastic. We can actually remain below 2 degrees C warming with quite a high probability. RCP 4.5, RCP 6 and RCP 8.5 would basically make all the sea ice disappear, which is bad. Many shipping companies and so on are salivating at the idea because you can go directly from the North Atlantic into the Pacific, and there is a lot of oil, gas, and so on, fossil fuels in the Arctic, buried from the time when there was no sea ice, and a lot of biology, like when the dinosaurs were wandering around the planet. So there are going to be some battles to stake a claim on this piece of land or a piece of the ocean or piece of the planet, which has already started with some countries putting flags in the bottom of the Arctic Ocean and so on. For sea level rise, Greenland is something to be watched very carefully. Seems to be showing accelerating loss of ice, mass and elevation. So there are small places where there is a bit of mass gain. This is August 19 relative to April 2002, but the trend, so here you can see water equivalent in terms of mass loss. So all the edges are basically losing mass, and top of the glacier on particular years like August 29 shows some gain of mass. But if you look at the mass change and sea level rise associated with the mass change, the scale is going down here, so increasing in millimeters due to the contribution from Greenland itself. And there is a seasonal cycle to it as well. This is estimated from satellites called GRACE, Gravity and Gravitational Recovery and Climate Experiment, I think. So there are two satellites moving together, and the wobbling of the satellites around the orbit gives you a sense of change in mass along the way. So two satellites are combined, and 2020 I think here was projected, but you can see that the news is not good. And if you remember your ice albedo feedback, this is the runaway abrupt climate change kind of situation where warming, loss of glacier means increasing albedo and amplified warming and continued glacier loss. There are very unique situations happening here. Glaciers melting on top of the center of the Greenland are burrowing into the glacier, creating what are called moulins, big waterfalls drilling down to the bottom, and then they lubricate the bottom, so make it easier for the glacier to slide and move towards the ocean and accelerate the loss, and so on and so forth. So there are really sad pictures of moulans, M-O-U-L-A-N, that you can find online. Okay, Antarctica, again, bad news. Lots of warming happening here. So temperature trend in degrees C per year. The scale here is 1,000 kilometers, and you can see East Antarctica and West Antarctica. People are watching very carefully. West Antarctic ice sheets, ice shelves carving off, breaking off, creating all kinds of cascades into glaciers sliding because of the loss of carving of the ice shelves that we just talked about in the previous podcast. Site of former Larsen B ice shelf, which broke off I don't know, a few years ago. So West ice shelf is considered unstable, I think. So this is a complicated situation because a warmer ocean can increase snowfall and create accumulation of glacial mass in some places, whereas warm ocean can also break off the ice shelves and increase the carving and so on. So there are regions where there is some cooling going on, but one has to be careful about the net effect on the glacier loss here. So Antarctic ice shelf thickness changes. Note the rapid thinning of the Pine Island Glacier. Somewhere here. This is the West Antarctic ice sheet, and Pine Island Glacier ice shelf in West Antarctica from this is a bit of an old paper, but this story continues to grow. So this is the West Antarctic here. These are the regions where temperature is cooling. This is the warming we have seen before, and there is the bathymetry that is being shown, and this is the grounded ice sheet loss in gigatons per year. So the thickness change, delta T over time, ranges from losses of 7 meters per year to few places where there's gain of 3 meters per year. So obviously there are places where losses are quite severe, and there are some places where there is a little bit of accumulation and thickness in ground ice. Okay, so this is the accumulation of I'm not even sure what. Yeah, so this is the Arctic sea ice loss, coming back to gigatons of loss. So there are variabilities. This is the annual cycle. So this is the mean of 1981 to 2010, and you can see that there was a record loss in 2011-12, and 2021 was, I think, the second lowest sea ice extent in August-September compared to so 2011-12 was the record low, and I think 2021 was the second lowest over the same period. So here is 2019-2020. So there is interannual variability in the ice loss. Again, we worry about the boreal summer loss because that is the one, the larger the extent at the end of the boreal summer, more likely it is to recover during the fall and winter months. Showing again the extent here, more later data from Vox, fantastic journal that puts out good science article. So this is the current year from last year. You can see the extent is one of the lowest over 1981 to 2010. And the median value is shown here, 10th to 90th percentile and 25th to 70th percentile are shown here. So the minimum in September is always to be watched for, because if it drops too low, then the sea ice is not going to recover during fall and winter months. This is something sad that is already happening and is getting worse. So in terms of climate indicators, this is something that will happen probably in my lifetime. I'm old, but many young people will see horrible sea ice loss over the Arctic. So this is again Arctic sea ice extent. This was the extent. This is the showing September to December, showing the 1980s mean here. 1990s mean is lower. 2000s and 2010s. So you can see that the record lows before the ice recovers. The current 2020 was down here, which is just focusing on this part here. So bad news all over. And you can also look at it this way: sea ice extent in millions of square miles. So it's the time series from 1985 to 2010. So 5-year ice. So how old is the ice? How long has ice volume survived? So 5+ year of ice has reduced to a great extent. There is still a little bit more of 4th-year ice, 3rd-year ice. A lot of it is 2nd-year or 1st-year ice, which means that the ice is not surviving very long anymore. We don't even show the 10+ year ice here in this time period. One can argue that maybe this is decadal variability, but this comes down to how you estimate risk. You can dream saying that this may be decadal variability and maybe ice will recover, but if you look at multiple evidences together of increasing CO2, sea level rise, precipitation changes, humidity changes, polar amplification and all that, you know that this is a trend and not really a decadal variability, or the decadal variability is very severely being modulated by global warming. Okay, so that's a quick introduction to Arctic sea ice and Antarctic and Greenland glacier trends. We will come back and look at just a little bit more about the glaciers, because there are specific processes called hysteresis, which you may have heard of. The glacier response to warming and cooling need not be perfectly symmetric, and these can have consequences. Plus, what do the projections say about Greenland, for example, with the worst case scenarios of emissions and warming? And the news is not good, as we will see in the next podcast. Okay.